Action.
All right, here we go. So we're going to start with is converting a Tracer Summit database to Bridge. I don't know if you guys deal with that too much, but in service, that was kind of our bread and butter, was taking old BCUs out and converting them to a Bridge and put them on an SC. And how you do that is you use the Bridge utility. It's not popping up, 1 second. Here we go. So we have the Bridge utility right here. So the first thing you do is you back up your Tracer Summit database. I guess we could try and do that really quick. So we'll open up Tracer Summit, just in case you guys aren't familiar with it. Go to Lincoln 2, put your password in. Got your site right here.
Wow, is that a beautiful front end or what?
Good old Comet Tower 2. So you go up to Tools here, you go to Backup, and you go to Site. There we go. Hit Add. Hit your location. I have one on here. The folder I want it. It's already the backup, but we'll just replace it. Hit Next, and you can hit Backup here.
By the way, it's always a good idea, don't name your job site backup.
All right, so now we're done with that. We could exit out of here, out of Tracer Summit, because now we have the Summit database. So now we go under Bridge Utility here. The first step you want to do is get your backup in here. So all you have to do is just browse the requested file name here, and then you just go right to where you put your backup, which is desktop. And here's our backup right here. Once you're done with that, what you want to do is you want to create a name for your bridge, essentially. So you just go under Create here, and you create a new legacy database. You want to say yes. And then I try to keep it in the same folder that I have my backup as. So I just go to Desktop, Legacy Class, and then I'll just put Comet Bridge. And I'll just hit Save. Once I have that, you start dragging BCUs over one by one. So all I have to do is select the BCU. You can see there's actually only 4 BCUs here. This one kind of actually burned. This is the first time I did this big of a site. But sometimes one BCU will create 2 bridges, because the old BCUs you actually could have 4 COM4 links, 3, 4 COM4 links. So you just got to be careful when you're dragging BCUs over, because you might actually have 2 bridges that get created. So then once we take one over here, you just drag it over, and you can see this one already created 2 because there's 3 COM4 links. So you can see your addresses right here as well. You have 128 and 129. These are what you need to address your bridges, so that way when the database goes in there, it gets pushed to these correct controllers here. And they tell you where the COM links are getting mapped to right here. And then you can just come over here and then just do another BCU. That one was just 1, because there's only 2 COM4 links. This one's going to create 2. Oh, go ahead.
So when this creates it, does it actually make one site with all the
Yes.
bridges on it? So it's
Yeah.
not, oh,
It's just one site, so when you get it connected to everything, you have to push the database into every single bridge, but it's only one site.
okay,
Then you're
nice.
pushing into multiple bridges. So you just take this over, drop
Now,
that.
do you have to do them all at once, or can you do them one at a time?
I'm just doing it one at a time right now. I mean, I don't know if you do them all at once.
But if you didn't add those other BCUs, you could just make one site for the first BCU, second site for the other BCU if you wanted to.
I don't know how that would work, because you're taking the Tracer Summit database, you're using that to create the bridge one. So I don't know if you'd be able to create multiple sites out of 2 BCUs out of one site. Is that what you're kind of insinuating?
Well, like 2 summit sites, the
Two
bridge
summit
sites
sites?
off one current summit site.
I don't know. I haven't done that before, to be honest.
Now you got something to do this weekend.
So here we go, I got them all over here now. So we're up to 133, so those are all the device addresses, all the comm links where they're gonna get landed. So once you're done, all you have to do, essentially do, is just hit save.
So seeing this makes me think that we probably should run this during engineering to put all those addresses on the drawings.
Yeah,
It's really nice too, because like when I did this job, what I had to do, so I didn't get confused, is under current projects and comment here, I had to make this document to try and help me out. I don't know if this is right or not, let me see. Might have deleted the document. Ah, there we go. So I had to go through and create this because this gets really confusing. So I was putting BCU link 1 to bridge 128-4A. So I was trying to map every single link so that way when I was doing with the electricians, I knew exactly where everything was getting landed and how it should be. So BCU 4, that's, it's going to 2 different bridges, or well, actually this was only 1, but BCU 1, you can see right here, you have link 1 and 2 going to address 128, and BCU 1 going to link 4 for the 129, so that way you're going to 2 different bridges for one BCU. So it kind of helps mapping this out here.
And I'm guessing you have to do this all together, because if you created one site for each BCU, you can have 128, 128.
Yeah, you can't have one
Now, but
to
you
get
can change
that.
that instance, can't you, afterwards or not?
I do not believe so, because when you go to the bridge utility, I don't think they get actually, we're right here. I don't know if they let you.
So, yeah.
Gene panel properties, let's see. Oh, okay, I guess you could do that. I never had to do it before, but you could change the actual address, so I guess maybe you can. So that's kind of nice.
This just does it for you.
Yeah, so
Yeah.
I just use it and put
So
some.
best practice is do them all at once. Yeah.
Exactly, correct. So once you're done doing this, essentially everything's set up. You got all your BCUs over on the right-hand side. It created all the device addresses, tells you where the comm links are getting. All you have to do is hit save the legacy database, and you say yes. And there, you created the bridge database now for one of the sites. What that looks like, just so you know, under Tracer Summit, I already have this converted underneath here. So I already have it L2 Bridge, is what I named it as. And Tracer Summit is just a password for it. So when you actually come underneath here, these are all the devices. This is kind of what it looks like right here. And you notice when you go under the editor, you don't really get that much information. Tracer Summit, you would normally get the site, the controller configuration, the status, and some things in there. All it does is tell you is, what the type is, whether it's talking, and the name for this. When you do the bridge utility, it does convert all the old B&E box names, so you don't have to recreate those. As you can see right here, it automatically makes the names for you. That's the whole point of the bridge utility, and keeps the addresses the same way, so you don't have to do any re-addressing or anything. Any questions on that? I know it was kind of quick, but that's essentially just how you convert a Tracer Summit database to a bridge database.
Is that how you guys have been doing it, or you've been recreating from scratch?
Probably.
Yeah, that tricked me on Comet Tower too. I was like, why is it creating 2? I only had 1 BCU, and then you look at the links, you're like, oh, that's the reason why. So now that we got that part done, I just want to teach you guys how to actually address the actual bridge and download the IP address and actually see the device ID and what port numbers and everything like that. The only thing that's supported right now for the USB guys is your COM4 service tool. You can't use anything else. We call tech support, they won't deal with you. So you have to use your COM4. You have your dip switches right here. For the RS-232, you just turn 1, 2 off, and then all 3 of them on. They usually have a picture right here. Of course, mine's worn down and you can't see it anymore. But once you have your dip switches there, you have your mini monitor cable. You put your 9-pin connection here. Got your cable, and you can plug it in. So let's do that. And then just for you guys, I only have a BCU here, but it's the same thing. They have a mini monitor port right down here. You can stick this right into there. And one of the biggest things, just so you guys know, is it has to be COM1 or COM2 for your port to connect to a BCU or PCM or UPCM. And on top of that, you have to change your parity to X on and X off for your connection. So I'm going to go under Device Manager and just make sure that all that stuff is set up properly. So you have Device Manager right here. If I scroll down here, so mine actually did revert to USB serial port COM2. If you actually click on this, you could actually go to port settings and go to advanced and change this to that. Sometimes what you'll do is you'll get it says in use. You can just ignore that, just hit COM2 and just hit OK. It will give you an error to say OK. And then what I was talking, it wasn't parity, I apologize. It's actually flow control is what it should be. That should be X on, X off in order to connect to UPCM, PCM, and BCU. And just hit OK.
You have to make sure your event code rights are updated, or else you will not have access to change your ports. So that's why it's important to update that policy every once in a while.
The software I like using the most is BCU config, the utility to download and upload IP addresses to a BCU or a bridge. If you need to know where that is, I do have the link in there, but I'll show you really quick. It's just under computer, C drive, program file x86, tracer summit, bin, and then you have all your software right here. So you can use the BCU config or your BCU config telnet, BDT editor, which you might have to use sometimes because SC Plus doesn't work, trying to create a BDT table for certain ones. I've been having issues with BCU config telnet, so I've just been using BCU config to make that work. So I got all the cables connected, my port set up and everything, so now I could actually go under the BCU config and just try and do an upload and see what's actually in there. I'm just going to put this to port 2 because that's where my port 2 is. So this is actually what's inside this BCU right now. It is network number 1, device ID 1, and then you have that IP address, and the BBMD is enabled. So if you wanted to, you could actually change your dip switches, and then you could actually make it to 128, and then download it into there, and get all your address to what you need. Because it starts at 128 for your bridges, so you go to 129, 130, 131, and so on. Any questions about this? So I'll get an IP address in there, uploading it. Of course, you don't want the bridge to be a BBMD. The only one that you do want to be a BBMD, of course, is the SC for the most part. I had the wrong port in there. This thing's freaking out on me. Space is going by pretty quick here already. So what we can do now is, I guess, try and connect to a PCM right now, if you guys are okay with that. You guys okay with the bridge and everything? The PCM, you actually need to use the same exact thing, same exact setup. For a PCM, you have to have this connector here, mini monitor, and it just has a port right in here that you just plug it into. So this is the PCM, so I'm just going to hook up the PCM edit. The first thing I try to always do right when I get in the screen is just go to help in PC configuration. Tony says he was able to use his mouse on this. I personally have never been able to use a mouse. You always have to hit the letter and then F2. F2 is to enter everything in there. So I'm going to hit C and then F2. And then it's going to take me to my where I have PC configuration. So I'll hit E, F2, and then for some reason mine always says none on there, so I always have to put direct on it. And then just hit enter once you're done. I already have port 2, because that's where my port is. And then this actually is a baud rate, I already had to figure that out. Essentially, if you can't connect to the PCM or UPCM, you might have to play with your baud rate. And you have 1200, 2400, 9600, those are your 3 options to do that. But I already know 1200 is the right one. So once you're in the screen, all you have to do is hit escape, once you get everything in there, and then hit escape again. And then you go to PCM setup menu, so hit VF2. And then the first thing you want to kind of do is create like a database for it, so you can put all your PCMs underneath, like a job folder essentially. So once you're done, you just go to G, F2, which is PCM names and data directory. And then change or create data directory, DF2. And then you could type one in there, or actually, I apologize, it's supposed to be, that's not correct.
F3.
Yeah, that one I canceled. You're actually supposed to go to change or create data directory. I don't know if I did that or not. Here. Let's see. DF2. I have one called class, so I'm just going to hit F3 right now, but that's, you would just type in the name and hit enter, and it would create a new directory for you. So I'll just hit class. And then once you're done with this, if you don't know the name of the PCM, what I typically do is I go to PCM name and setup, so hit AF2. This is the actual name of it, but I'm just going to put PCM1, just kind of give you guys an example of what happens when you don't know the name of an actual PCM or UPCM that you're connected to. So I have PCM1 in there. I'm going to hit escape until I get to this main page right here. And now that I have that PCM created and I have my job file there, I can hit F2 and then hit F3, and then I have PCM1 right there. So now I can hit enter. It says, you want to connect to it? Yes. So it's going to try and connect to it. And now it's going to say, okay, well, here's your name. PCM1 is not the name of this PCM, so then you go back in there and you could actually change your name to what you have it for. So we can read it on. So I'm just going to hit no, and then go back. So G, F2, and then I'm going to rename the PCM to the proper one. Henry, and just hit enter. Now I'm going to go back and then select the right PCM. So F2, F3 to go for your list, and I have that right there. And just hit enter. Even though it says OK right now, it's still technically not connected to the PCM. I don't know why it always does that, but what you have to do now is go under I, F2, and you have to upload all the data out of the PCM so that way you have it on your computer. And that gets all your files that you need for it as well. And you can see live points and everything. So I'm going to hit IF2. And then I just want to upload all data from the PCM, which would be BF2. Now it's trying to connect to the PCM. Just hit enter. This one's been powered down for a while, so just asking for time and date. You don't need to do that, so just hit enter right now. And now it's uploading all the information. Sure. Tony?
Now, do you guys understand this F2 key thing? Okay, because this was built back in the days, this program was built back in the days before GUI interfaces or mice. And everything had to be run for the keyboard.
Built before TV existed also. DOS program.
The only time I've seen this done was when we did the Arlington Hotel, and he took a Tracer 100 and put it in an SC.
Now you might as well go grab coffee or something on this, because it takes a while to upload this stuff. The UPCMs I think might be a little worse, but it takes a while to get all the information out, so you got to be a little patient with it.
You gonna tell them what it doesn't pull up? The one thing it doesn't pull up?
What does it pull off?
The names of the PCO routines.
Yeah, because you just have like the A, B, C, and you just hit F2 to select it, yes.
I thought I listed that once you went with it for you. No, it doesn't pull the name out.
Yeah, you don't get no names of the routines. They just have them like listed kind of 1, 2, 3, 4, or whatever, it's just kind of like an
Say
order.
the CD, the 5 on a page.
Yeah,
So you have to like scroll to the
Yeah.
end line and see what point of control.
exactly. And this actually has a lot of routines in it, so we'll actually, we'll see the routines, and reading them too is kind of weird because you have to go from right to left to read a PCL routine for PCM and UPCM. Instead of going left to right.
The bad news is this takes time. The good news is once you have the file, you know absolutely everything about how that controller is running.
Yes.
The Allotone's pretty crazy, because they went from the white screen and having to type everything in to, I mean, they just click the little arrow and change the set point? Yes, that's all you need to do now.
That's what I was in line. Get yourself some coffee when this is going on, and 5, 10 minutes, and by the time you come back, it will probably be ready to go.
And you guys think about all the programming you have available now in a UC 400 or a 210 or a 600. This thing, you had 20 routines you could program, and each routine had 20 lines. So you had a potential of 400 lines of code you could read, you could do. And something that you do in one block with TGP might take you a whole routine in this. So,
A lot of ROs and LOs.
I think the hardest part about looking at PCL routines is following the variables.
yep.
Tracking, all right,
Yes.
here's where I change this, you know, and then comparing these two and setting it to this one, and that's being used down here, it gets really confusing fast.
And
It
the
is
other-
a nice thing.
And the other thing is all the logic is done with L for logical variables and R for real variables. And you only have 4 of each to use. So sometimes if you need more than 4 logical variables in a routine, you use it up at the top, and then when you finish the logic with that, you reuse the variable again in the same routine, and it's actually a different variable at that point. So,
So right now, it finally did upload successful. So we could just hit escape. Now we're kind of connected live to the PCM now. So if you wanted to go to point data, you could hit AF2 and essentially see all your points on here. PCMs and UPCMs are a little different on how you see everything. PCMs are a little easier because you can just hit CF2 and you can see all your current point statuses right here. All your analogs, outputs, your binary outputs, binary set points and everything like that. So you kind of see all this. So if you hit F3, you can actually see next and previous. So we'll hit F3, and these are where your analog values are. And now we're getting the binary. So we have our binary inputs, binary outputs, everything that's created there. We get more binary set points. I'll hit escape right now. And then we'll actually look at one of the PCL routines. CF2, and then we'll just look at the first one. Yeah, so we have routine number 1, 2, 3, 4, 5. Even it keeps on going down with the numbers, but you want to, it's always A, B, C, D, E that you have to actually put in there. So we can hit AF2, and that will take us to our first routine right now. So this is kind of what like Tony was saying, you have your RO, LO, L1, L2, and those get reused quite a bit, where you can see L1 or LO, if true, then it exhaust interlock control on, essentially. So that's what it's trying to do. So 4 minus the boiler room set point equals RO, and then boiler room set point is greater than room temp equals LO, and then 85 greater than room temp equals L1, and then of course RO less than room temp equals L2. So that's where they're trying to get you to do L1 or LO. If it's true, then you actually have your exhaust interlock and control the fan on. And then if true L2, you know, where it's below, then you control your exhaust fan off. So it's just a simple PCL routine to turn on or off an exhaust fan based off space temperature.
And this is a good example of how not to write the program. Because they have one set of logic turning something on and another set of logic turning it off. Whenever you do that, you have the possibility that you forgot something. So it's always a good idea to write half of it. Write whatever turns it off and then put an else statement and turn it off.
Real quick, you were saying read right to left by.
Yeah, so I mean, you have your second argument, then you have your operation, first argument, and then you have your result. So it's technically you're going right to left because you're getting your result on your left-hand side.
But isn't it technically the first argument, operator, second argument gives you the result?
Yeah, but he's saying that what you're really looking for is,
The right side.
the left side is what the final thing
Yeah, the
that happens,
result,
not
yeah.
the right side.
Okay.
Yeah, I guess I was reading it wrong. I guess you're saying your first argument, operator, second, and then you're going to the left. I was just trying to say that kind of the values on the left-hand side, so
Okay.
where you're kind of reading that.
Okay.
Let's see here. DDC loop parameters, those are pretty much PID loops for the PCM and UPCM. So if you wanted to, you could actually go in there and hit, BF2, and then upload DDC parameters from PCM. So you guys could go in there and do that. Let me see what AF2 would let you add any of them. But right here, you have your proportional gains, integral gains, action, reverse, pretty much everything on a PID loop, but they call it a DDC loop in the PCMs and UPCMs. Same principle, 4-to-1 ratio is what they have it set up for. And the same thing with your action with reverse or direct. So then you have your min and max and all that kind of stuff. Then you have your air band too. So very, very similar to a PID loop if you guys are trying to use that in a PCM or UPCM. Oh, yeah. Seems so much more when I was on there. Oh, CPL.
How do you, I was gonna say, how do you create?
How do you create a point? So you just, I did it, actually, BF2, I got kicked out, so I can sell right here, select the PCM, so I'm still connected to that PCM right there. So if you go under point edit, so AF2, you have analog point edit, so I could hit AF2, and you could actually go right here and get your point right here. So you have analog input 1, 2, 3, 4, 5. So analog input 6 is still open. We get it F2, and then you can go in and select what you want to for your point right here. So
And in PCMs, you did not have universal points. They were either analog or binary.
yes, and then once you created two, I'm not sure you actually had to download it because technically that was in there. So now you have to go download data to the PCM. So once you're done creating your points, you still got to download it in there. So don't forget about that. If you make any changes, you still got to download it in, or it's not going to recognize it. And then all the changes you made are going to be gone once you disconnect and everything. So just be sure to download the information once you're done.
Is that just for points? Like if you write a PCL or to make a change to a PCL program,
You still have to download
you
it.
have to download that separately from this page?
Yes.
Okay.
Yeah.
There is an all download.
It takes a long time to do that though, because it goes through every single PCL routine and it downloads them all in there. So you're going to be waiting a long time if you do that.
Does it whether you have something there or not.
You could download,
Yeah.
like if you added a program, you just download that one program individually.
I don't know. I think you can do one at a time.
Yeah.
Okay. Yeah. So you do one at a time on there.
It's also why I'm really glad that they, TGP2 calls it receive from controller
Yeah.
and send to controller. Because they swapped download and upload sometime long ago.
Yeah, when Train
They
first
believe
came out
that's
with
the right
PCM
way.
Edit, that was before the days of the internet. There was no upload and download. So they decided sending it was downloading, and the internet decided sending it was uploading. So I think everybody is used to that reverse of terminology,
But I like send to and receive from way better.
yeah.
Oh, I know this one, I do that,
All right, let me double check what I'm doing.
One thing that's nice on this, I mean, at least coming from the service end, is, you know, they have a test mode for PCM and UPCM, so if you actually go back to point data AF2, you actually do IF2, which is input-output test. And what it's gonna say is you're gonna put this in a manual mode, and once you're done, you wanna actually make sure you release that back to an odd, like back to the mode it was in. So you just gotta be careful with that. So I'm gonna hit yes, I really do wanna put it in manual mode. Just hit Y, and then once it uploads everything here, you could actually just hit the down arrow and you know, change like the exhaust to on. And then you just hit enter. Then it's downloading it, download successful, please wait. And it actually just turned binary output on right now. So it kind of helps you troubleshoot stuff if you guys ever did get in a pinch to use, you know, this test mode kind of to, you know, test the points and analog outputs, binary outputs. It definitely does help out. So I can put that back to off.
Now, if you do that, does the programming start over from scratch, or does it go back to where it was before you started the test mode?
It should be back to where it was. I mean, I don't have any issues like where a program restarts, like if you try to start an exhaust fan, you know, I mean, or a supply fan, and you release it and you put it in regular mode, I mean, it should still be running afterwards. I mean, I haven't had an experience where a supply fan turned off on me after I did all this, so.
It doesn't carry its priority. It will wait for the routine to go back that was running.
Okay.
So it doesn't hold a priority in there and release it.
Okay.
So once you hit escape, it actually does give you the option. You could actually just hit F1. It gives you the previous mode that you were in, so that's kind of nice. Usually it's auto remote, you know, that means it's going to the BAS system. So you can just hit F1 and, you know, it'll go right back to the previous mode, back to the BAS mode on there.
Can you pull that screen back up?
Sure. Wait, I have to. Yes. And then you just want me to exit out again, back to that, okay. Escape.
Okay, auto remote means the panel goes into auto, and if there's a higher level BAS, like a tracer talking to it, it will take its set points from there. Auto local means it will run in all its programs automatically, but it will not be using data from the front end. All your analog and binary set points that are going to the controller will be controlled at whatever the local value is, the COMLOS value.
I could see where that could probably.
And where that really burns you is if you're working with a heating or cooling plant and it's winter timeout and that thing is running in a winter mode, or let's say it's summer timeout, it's running in a summer mode. If you put it in auto local, chances are good the default value for winter summer mode is always winter mode because you want to fail for heat. So then you wonder why the chiller shut off and all this other stuff happened. So you have to make sure if you're running auto local that you've got the default values for all your set points right.
And then I have been to quite a few job sites on Tracer Summit where the customer puts in the manual control and he's wondering why things aren't working right, because once you put in the manual mode, whatever you set those values to, it's staying that way. It's not moving at all. So you can actually leave it in a manual mode and exit it, and whatever you set those, like the valve at 50% and fan on, well, the fan's gonna stay on and the valve's gonna stay at 50% and nothing else is gonna happen. So that's just something to be cautious about it, you know, too. Maybe someone exited out of PCM, edit, and left it in the manual mode or something like that. So just be careful about that too.
Where would you find what mode's running?
Usually Tracer Summit, it will actually tell you, like on the front end, it will usually tell you whether, I don't know if it does it on an SC or not, but I know on Tracer Summit, it would actually tell you, like when you're in the editor, it will say, I think it's all the way to the right, I forget what the tab is, but it says like auto, remote, local, or manual, it will actually tell you that. And I want to say in Tracer Summit, I think you actually have the capability of changing the mode on it too, so that's why the customers could get in trouble because they could go in there and actually put it in the manual mode and forget about it or something, so. They do have the capability in Tracer Summit to do that.
Yeah, there was no timed override on these things for manual mode. So
Mike, how do you get your, I've gotten this document before where Tony's helped me get it before, where it's like a Word document or whatever that
Yes.
has like all the points and the PCL and
I'm
everything.
actually not that great at it.
Okay.
Tony's actually gonna show you how to do that. We can actually, once I'm finished with this, then he's gonna come up here and show, because that print document's awesome, because at the bottom of the PCL routines, it separates them individually, and it just gives you the text of how the code works. So it's great when you're trying to read programming. You just kind of read the bottom of the code without even reading the top, and I mean, you have the whole sequence of operation right there. So it is kind of nice having that file for sure when you're reprogramming. Any questions about PCMs or connecting or kind of reading this stuff? I do have the documents I gave you. The last thing I kind of wanted to go over was just some CPL with Tracer Summit. So I'm just going to kind of show you best practice how to create a CPL program in Tracer Summit. So then just hit DF2 and then you'll get out of here. So just in case you guys don't know, I mean, you just go under setup here and then custom programming. And then I'm just gonna teach you guys how to do a real simple, economizer, enable, disable program. Just to kind of show you the best practices, how to write a code hopefully without making so many errors. So of course you always have to have a program up top, so that way it knows the name. So you give it one space, then your name has to be all together. You can't have spaces or anything like that, or like kind of special characters. You use an underscore, but you can't use like any crazy characters in there or anything like that. So I'm just gonna call this one the econ enable. And I'm just gonna hit enter to go down. The first thing I wanna do is define my points. So your best friend is up here is edit. So when I come up to edit here, I wanna add statement. And then you have definitive, which is just a whole number, a definition of a whole number. So I'm gonna hit OK, and then it throws it right there. Once you're done, I wanna define on and off essentially. So I'm gonna put on equals 1, and then how I'm gonna divide that, so I can put the off, is just put a comma here. I'm just gonna put off, and then it equals 0. So now I kind of have my points, kind of defined for my on and off. Now I could kind of get like my statement here. So when I come up to edit again, and I hit add statement, I'm gonna scroll down. This is pretty much the bread and butter of CPL or if then else statements. So I'm just gonna hit if else, and it inputs it right there for you already. So I'm gonna write my statement up here. If outside air temperature is less than 55, then enable economizer, else disable it. So just something real simple. So they already have an outside air temp sensor in this site. So I'm just gonna go under edit, and then I wanna add an object name and property. So that way you can see the object name and the property of that object. So I'm gonna use analog input, and then they have the outdoor, outside temperature right here. So I already have it selected right there, so it popped up right there. So all I'm gonna do is just use the less than statement, and I'm just gonna put 55, and now I have my argument already ready to go. So all I have to do is just kind of select right down here, and then I can hit edit, add statement, and I want it to control on if that's true. So I'm gonna hit control, and then hit OK, and then select my points. So binary output, they have the economizer, and I'm just gonna hit OK, and it's gonna ask you, what do you want to control this to if that's true? And I'm just gonna put on, and I'm gonna hit OK. And then pretty much else, if that's not true, you just want to control it all. So I'm just gonna go right back up to edit, and then hit add statement and control, and then go right underneath here, go back to binary outputs, economize, and then it's gonna say, what do you want to control the value to at a 5? And you can change the priority up and down, just so you know. And you can set it to release. I always just do set, so I can put off, and then hit OK. That implements it in there. Essentially the code's pretty much written, but at the end of a program you have to put end, otherwise your program will not compile right. So we have the end if now, so now I just got to write end. So now the program's completely done, we want to compile it, and there you go. So now I have an econ enable disable program right there. I mean, I know it doesn't have a deadband in or anything, but It's just kind of nice when you use edit, because it just leaves you less errors of actually writing the code through CPL. Any questions about that?
And if you don't do this all the time, it's a nightmare.
Yes. I'm not an expert on this, and I stumbled through it.
You know, a single space
Yeah, it was just, that was my.
will mess
Yes.
things up. This program is extremely difficult to work with.
My very little experience with this, we used to have to write code like this for our, they call it 242 man, which is pretty much a big switchboard. And you have to write, if this person calls this number, route to this. And the implications of putting one space in the wrong place,
Because it doesn't work.
it's a nightmare. And then you have some poor guy going through 4,000 or 5,000 lines of code trying to find that one space in the wrong spot. You gotta be real careful with this stuff about spaces, about parentheses, about any equals, commas, anything that's in the wrong spot, it will not freaking compile, and you'll pull your hair out trying to figure out why.
And like, you didn't have the and on there, you try to compile it right now, I mean, just something is that stupid, it's gonna say line 12, there's an error right there already, because I don't have the and on there. It doesn't know when to stop.
See, at least you guys have that luxury. The military, we didn't have that. There was no such thing as compile, either ran or it didn't.
Yeah.
And you got some literally like hours just trying to find a space.
You know, you miss a dot.
Yep,
right
miss a
here,
dot, miss anything.
compile, and it's gonna give you an error line 5. So, I mean, that's why I try to always use the edit, and then just, you know, add statement and function, add object and properties, just makes your life a lot easier. It kind of compiles everything for you already there.
Yeah, if you notice when it was reading the point, there was a dot between the object and the property, but when it was controlling the point, it put a comma.
Yes,
Huge difference.
And
and your whole program will fail if you don't have that set up right. So,
I know what to do though, if I screw it up. Just call Mike or call Tony.
like Tony was saying too, I mean, I don't know if we get this to work, like if you have like a dot, like right now we know that it's not gonna compile right. I still think they're gonna get errors, but you could actually add 2 slashes, forward slashes, and it pretty much takes that line out of the picture. I think it's 2 for a comment.
Correct.
So compile. So now it's saying that, okay, well, we have an if, but we have a then, so it's ignore that line. So that's how you add a comment, and there's two forward slashes. Or I mean, if you guys want to make a, you know, a note right here, you could be like, you know, this program, you know, controls whatever, you know, so then you could actually still compile it, and it will still work just fine. Well, let's see, first line. I saw the dot in there. So right here, I forgot to add a period, so it compile now, it should work, even though I had those 2 slashes there. So that's how you like add a comment or take a line out of the program to try and help with that. Real basic, but hopefully just kind of best practice to kind of help you guys out to maybe writing some code or maybe understanding a little better. That's all I have. So,
Like, can you just show where to go to look at existing CPL? Like, if
yeah,
you're
sure, oh yeah.
getting rid of
Yep.
Summit, or then you want to make,
So if you go under program here, you can actually open CPL object, and then these are all the programs that are in the site right now. So I mean, we can just go up here to AC Unit 3, and this, I don't want to save that. And this is one of the CPL programs that are in here right now. So this is controlling an AC Unit 3-7. So you have your your definitions right here, like I said, integer, so on equals 1, unoccupied equals whatever it would be. I don't know if that's 2 or whatever it is.
it's off.
It's
0.
0 is for unoccupied, so an office for 0, occupied equals 2, so it kind of gives you what it's going through.
Yeah, if there's no equal sign after the variable, that means it's a 0.
Okay, gotcha. So there you go. So that's that. And this one's pretty simple actually. 3rd floor after hours space temperature present value. So just looking at the actual space temperature is greater than the actual space temperature set point, or 3rd floor area present value is unoccupied. Then control 3.7 fan control on. So that's just, you know, essentially how you read it. It's really not too bad. I mean, to do that. Still kind of like PCL routines a little bit.
I don't know if it helps, but the difference between the period and the comma in those statements up there is actually similar to a few other programming languages, where the comma is just like it is in our English language, it's representing a list of things. So if you see control AC37 fan control, comma, present value, comma, on blah, 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 it's, you're passing a list of variables to the control function. So that's what the comma is doing. The period is actually representing property. So you're taking property of a property of a property. So in other language, I don't think you do it in CPL, but you could drill even farther one way or the other by putting more periods with more properties and keep going like that.
And then, I mean, another good thing too is how many brackets have you on the left side? You need to have the same brackets on the right side. So I mean, that's just, you know, a tip. I mean, you can see there's 2 brackets here, one here, and then there's one here and one here. So if you took this one out right here, of course, the program wouldn't compile right. So when you're dealing with the brackets, you need to have the same on the left side and you do on the right side. Otherwise, your program's not going to even work either.
And make sure to pay attention to the difference on there between the brackets and the parentheses.
Braces.
Yes. So, local state values, just so you know, local state values are usually to that program. I know you can send them to another program. You can reuse local state values, which if you look at Sid's program, it'll make you want to blow your brains out because he likes using local state values. And he would send one to another program, to the next program, to another program. There was 3 programs controlled at one point with all local state values. So it was, I couldn't even read it. I couldn't even figure it out. That was actually a tight shot. So it was really interesting.
He's been retired how long now? He could probably still tell you what those programs do.
I'm sure. I don't know how he did it, but I couldn't figure it out.
Rubik's Cube is
That comes from working on missiles for 10 years.
it. Yeah, you don't want to make it too easy for other people to figure it out.
Yeah, I guess that's all I have right now. So any other questions or some basic CPL, PCM, bridge stuff?
What is CPL stand?
Custom programming language,
I was just thinking computer programming.
What does PCL stand for?
programmable control module,
PCL.
programmable control language, programming control language. Okay, all of our old controllers, and that's PCMs, UPCMs, and Tracer 100s, have a lot of programming that is built into them that we didn't have any way to easily upload it and be able to tell what it's doing. So a long time ago, one of the train franchises had a computer programmer on staff. And this guy figured out how to take a save file from a Tracer 100, from a PCM, and from a UPCM, and he wrote a program that takes the save file, decompiles it, and puts it into a single document that you can read. So the guy was a really smart guy. Now, back then, we were telling the train company, we need this utility. And they said, there's no need for it. We're not going to invest the resources to do this as a company because it has no benefit to us. Now, it had a huge benefit to the field, but not to the train company. So what happened is this one service company paid this guy to do this, and I don't know how much it cost him. But if you've ever looked in your software catalog in Tech Data, where's your Tech Data?
It's right in the middle there, up a little higher. It's all the way up, right there. You already found it.
There, thank you. If you go into your software catalog in Tech Data, you'll see this thing called TTSI. Now, it's intuitively obviously that that stands for Toledo Train Service Incorporated. Okay? And that was the franchise that had the programmer. So the program became known as TTSI. Now, Mike was alluding to the fact that PCM is a little bit clunky to work with PCM edit because you have to hit F2 and F1 and all this other stuff to select menus. All right, now I want to know by a show of hands, how many of you can run a computer from a DOS prompt? Okay? When we are dealing with legacy stuff, we're literally talking about DOS prompt programming because Windows 3.1, which was the first GUI interface, was not created when these programs were. So because of that, to use this TTSI program, you have to run it from a DOS prompt. Now, you guys all know how to get to a DOS prompt, I'm assuming, from Windows.
Windows R.
But before that, I have to warn you that this TTSI program will not run on a 64-bit machine. Okay? So you have to run another program to make your computer stupid. Are you guys all familiar with DOSBox? Okay, well DOSBox, they built it into the executable for PCM and UPCM and all the old train programs. And what DOSBox does is it dumbs down the operating system so it can run with that old code. But we have to do the same thing with TTSI. So I'm going to go in here and run DOSBox. And of course, like all good programs, it doesn't tell you what you need to know. I have a document that we'll put in tech data that is going to be called How to Print Out Old PCM or UPCM Controllers. And it has screenshots and everything else in it. But one of the things you have to do when you're running DOSBox is you have to mount the drive. So you have to mount C space C : \\. Okay, you always get this nasty thing that says this is not recommended. And of course you say that's fine, I know what I'm doing. So now this is a DOS prompt. You guys know what this looks like. So we have the DOS prompt and we need to navigate to the directory where that TTSI file is. So do all you guys know the dir command? Holy crap. Okay, when you're running from a DOS prompt and you want to know what's in this directory, you used to hit dir. Okay, and that will give you the names of all the subdirectories and the files in there. Okay? Now, the first thing you see is I'm on the Z drive, which I don't want. So I'm going to change it to the C drive. We hit C:. When I hit the directory command, the other thing you will notice when you're running DOSBox is this is the day, back in the day, when you couldn't have directory names longer than 8 characters. So what it did here is it truncated all the directory names. Hopefully you guys know that your Chicago train tech data is under train Chicago tech data. And if you notice right here, there's a directory called train C:1. And the tilde1 means that this program can't read all the characters because it was only based on 8 characters. So it puts this tilde1 there. So to change directories, you hit CD and a space, and then you hit train, and you have to use the tilde1. What'd I do?
Train C.
Oh, train C. Thank you.
CD, train C.
Sorry. Change directory, train C tilde1. Okay, now I'm in that directory and I want to see what's there. I happen to know that what I'm looking for is software, because that's one of the directories in there. So I change directory to software. Okay, and then I want to see what's in there. And
By the way, if you guys know you're gonna be using this, if you're gonna be using it multiple times, just copy that to your C drive instead of always having to type in the directory path to.
yeah, you could put TTSI on your root directory.
Yeah, you can just put that whole folder on your root directory, and then all you gotta do is punch in TTSI.
So I'm going to change directories again to TTSI. And now I'm finally in, did I close it? I closed it, yeah. And within this TTSI program, you see the executable files here. There's a get executable, there's a get PCM, and a get UPCM. And these are the three programs. Get is what you use when you have a Tracer 100 save file. Get PCM is what you use when you have a PCM save file. And get UPCM is what you use for a UPCM file. Now, this program is really clunky and you can't move around in directories. So you have to make sure that whatever file, whatever save file you want to operate on is in this directory. So now what I did before class is I took a unit vent PCM program that Mike had on his computer and I put it in this TTSI directory. And that's the file called univent. So what I'm going to type now is I'm going to say get PCM, and then you have to put a space, and then you put the file name. And the name of that is called univent. Now you'll notice that a save file on a PCM actually has 6 different files in it. There's one for some programming, there's one for a display, there's one for points. You have to have all of those files there. This is all detailed in this, so you don't have to memorize any of this. But assuming you have all the files there that it's needed, you hit get univent, and you saw it working, and it says it created a 23-page document with 907 lines out of that save file. And now we can go in here with Windows Explorer, Windows. Let's see, where are we? We're on the C drive, right? Go there. This is real easy. Software, TTSI. And what you will find is one file. It's either usually a print document or a doc. And it should be called unitvent.pr. There it is, a PRT. You can tell by the date on it. And, I don't know, can you open this up with Notepad?
Yeah, just close out of that. Actually, you should probably do this for DOS. Right click,
Yeah.
open, select program from the list.
Yeah. And you can use either Notepad or Word, either one. And what this will do is it creates this big report. And it has the thing here, it starts with analog points. This tells you all the setup for the point, for the inputs, the outputs. This has all the set points. It goes down here and has DDC loops. This is one of the best things I like about this. This tells you, I told you, you have, well, this, I forgot, PCM has 15 routines in it, I guess. These are the routines, and these are all the points in the controller. And if you see an R there, that means that point is red in that routine. So if you want to know all the routines that the room temp is being used in, this tells you it's read in routine 2, 1, 2, and 6. When you're looking at your outputs and you want to see where they're controlled in, you can see here the supply fan start-stop is controlled out of routine 3. And it's also read in routines 4 and 5. So especially if you're converting one of these to a UC 600 and you want to know where's the logic for that being used and where's it being controlled, this tells you what you need to know.
What's the CSD?
What's that?
What's the CSD? The little extra container.
I think that's the display. Because you have to have a separate file if you had an LCD display on the controller. I think that means it's in the display. And then it'll tell you for your 15 routines here, how often they're running and which ones are on and off. So obviously a routine that's off is never running even if there's anything in there. And then this is what Mike was talking about. When you look at the routine, the top of this looks like the edit screen that we saw, but down here it has what's called the expansion of local variables, which actually takes the point names and plugs them into the logic. So it's a little easier to figure out what's going on down there. Okay? But the cool thing about this is it gives you a written record of what that controller is doing. So anytime you're doing a PCM, a UPCM, or a Tracer 100, I would always run this before you start the job, so you have a written record of exactly what that controller was doing. And where this can be very important is when we're trying to change something and the customer says, well, it wasn't running that way before, you have written documentation that this is how it was programmed. Okay? I am absolutely astounded. I didn't realize we now have a generation of people that don't know how to run from a DOS prompt.
That's what I learned on.
Now, to quote my father, if you can't run a computer from a DOS prompt, you shouldn't be licensed to operate one.
Don't worry, we're not.
The first computer I touched, the 5 1/4-inch floppy disk, was the hard drive.
Yeah.
That's it. There was no mouse, there was no nothing, just type. I feel old now.
Is that it?
That's it.
That's it, yeah.